helpful I will be on this one, just glancing through it a few minutes ago.
Okay. We'll figure it out, I figure. Okay, so where is my quiz?
Thanks for always being so good about setting this up.
Oh, no worries. I always think I have the wrong time to my other group, but I'm like, wait, we didn't have it this week because the holiday and then the time changed. So.
Did you get a 0 on the lesson 9 group meeting or whatever?
I don't know. I'll have to check it. Why did we have a 0? Let me check. I know he was getting the wrong, I had the links wrong or whatever, but I thought I had that thing fixed. No, I have a 10 out of 10 on the group meeting for 9. But I put your name on there.
Huh. I'll have to just respond and send him an email.
Yeah. Yeah, I would say, because, yeah. Mine was graded. Oh, my grade in the course. See, I never look at my grades. I just do the stuff, and then I look at them, like, at the end of the semester. I never look at my grades, because it's just one more thing to look at. But
I have to know where I'm at, even if it's terrible.
it distracts me. I figure I do my best, and whatever it is, what it is, and then at the end, if I have to make up some extra homework or something, then I do it, a couple weeks toward the end. But the rest of the time, I just kind of do what I can and take what they give me. Except on this one, when I couldn't open the stinking Excel file for the quiz, for the exam, I was like, this isn't working. That was terrible.
What did you get on that test anyway?
I got... No, I don't mind. So the only ones I got wrong are the 3 that I didn't answer, and he gave me half credit. So I got like an 89.
Nice. Good job.
Yeah. I just kind of thought I have 4 hours. I'll figure it out. So
yeah.
Get it. How'd you do on it? Did you? Oh, wait, you said you didn't do very well on it, right?
Yeah, I got in the 60s, which I definitely need. I want to pass. I need to do better than that. So.
You know what I noticed? When I was posting our group thing, I want to say it was group 4. There's another group with some guy on it who just knows it in and out, and he was doing it on a whiteboard. They were like at a library on campus or something, it looked like. And he totally was just explaining this whatever lesson they were on, and I was like, I might want to go through and watch his stuff because it was helpful. I was like, that's really cool. He really had a handle on it. And then the other guy was asking the questions, but the first guy really knew what he was doing. So
interesting.
I never thought of using the group collaboration in that way, but there's no rule that says we can't watch.
Yeah.
So there might be questions that come out or explanations that people have that are helpful or something that we don't know on our own. Anyway.
Yeah.
I want to say it was group 4. I can't remember, but I think it was group 4. Okay, so if we start with number 3, how many are there? 14. All right. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25. So if we go back to the lesson, the formula for that was the beginning. Oh, crap. I already forgot the question. I am so bad about that. Let me put
margin of error.
I want to know the margin of error. That was up here. Okay. So if we have a 90% confidence interval, I just want to find the formula so we set it up the right way. It was right. Click here if you love math. I didn't even see that earlier.
Where's that at?
It's on the right-hand side of the textbook. There's a link just above section 4.
Oh, yeah. Uh-huh.
Click here if you love math. I don't know what that's for, but I'll maybe explore that later. Okay. So the margin of error is the confidence interval, right? And we know the standard deviation, or omega, is 50. So M equals, oh, I didn't realize you replied. I don't know if Laura's going to show up either. Okay. So it's M equals 2 times omega over the square root of the sample size. So it's, first we'll do the square root. So the square root of n of 25 is 5. So it's 50 over 5 times 2, right?
Where are you getting that that formula? Is it just below the purple?
It is below the 4. It's like 4.0 kind of. It's putting together confidence intervals for the mean when the omega is not.
Yeah. Got it.
Yeah. So if we use the margin of error, m equals 2 times omega over n over the square root of n, and we know omega is 50 and n is 25, so that makes it 20, which seems like a really easy answer. Like, that can't be right. Wait a minute, does this have to do with the 90%? Or oh, okay. So we need to use the applet to get the 90% of it. I was thinking I was missing something that didn't seem right for a 90% confidence interval. So we have to keep going. So for a standard normal distribution, between what two z-scores will 95% of the data fall? So we need to find, in other words, find the values minus z and z such that the area between them is equal to 0.95. So we use the normal probability applet. We open it, we shade the area between the two red lines, and enter the decimal value for the percentage in the area box. So like we did, you know, the backward, kind of doing it backwards, not putting in the z-score, but darn it, it didn't do what I wanted. And it's negative 1.645 and positive 1.645. So the z-score is 1.645 for 90% confidence. Just kidding. I'm just kidding. That's not how it works. I did that wrong. So instead of multiplying by 2, we're going to do 50 divided by 5, which is 10, times 1.645, 16.45. All right. Sample mean minus
1.645.
Yeah, that's the z-score. I swear I'm seeing something on the, but that's the craziest thing. I'm like seeing things. The corner eye. Yeah, the z-score is 1.645. So
is there a place for the z-score in that formula?
If you go further down in 4.1.1, it helps you clarify the percentage of the confidence interval. So in the example, it says what Z corresponds to 95% of the area. We need to know 90% of the area. So we use the probability applet to find the 90% of the area between the two red lines.
So the 1.96 is the 95?
Right.
That they have in their example? Okay.
Yes. So I plugged that in. So the answer is actually X minus the sample mean minus 1.645 over 50 over, times 50 over square root of 25. But if we solve that, then it's X minus, hold on, which one am I supposed to do? I'm still looking for the margin of error though. Oh, hey, I typed that wrong.
What do you use to calculate these out?
I just use my computer calculator. There's no symbol for omega on my keyboard. Oh, this might have the same problem. Walking through it. Margin of error.
There's a statistics calculator. That's cool.
Mine's just a scientific calculator.
When I click on view, there's standard scientific, programmer, and statistics on mine.
Ooh, maybe statistics. I just use standard and then it expands into a scientific. Oh no, mine's just scientific. Just kidding. It says scientific. I could do standard scientific, programmer, date calculation, converter, currency. Oh, look at this. All this stuff I've never even used. I just use scientific. So the calculation for 90%.
This is Stephanie from statisticshowto.com, and in this video I'll show you how to find a critical value for a confidence level. I'm going to use a 90% confidence level, but you can use this technique to find alpha. The way you find alpha is you want to subtract 90%, that's our confidence level, from 100%.
Oh, that's not what they had.
Gives us 10%. If we turn it into a decimal, 0.1. This alpha level is the area in both of these tails. What we're interested in is this critical value here, so we need to do a little more math.
Okay, nope, she's not doing what I want. Not watching you. Okay. I forgot that was alpha though, so that's handy to know. Okay, so I need to get, I know the confidence level is 1.645. That's going to be standard. Any 90% would be 1.645. Insert the values of the formula, so it's Z times, Metal on a proportion. Because that's a proportion. I'm not doing a proportion.
Excuse me.
We don't have a percentage. We have if your critical value is 1.45 and your standard deviation. Yeah, but what? No, but I still have my. Okay, whatever. I'm gonna go back. Wait. Right, confidence interval is different than the confidence. I mean, confidence level is different than the confidence interval, which is the same as the margin of error. I got that. It's called.
Getting to the point where these calculators are difficult for me to do with the tools I have available.
Oh yeah. It's not it. Oh, okay, it is 16.45. That's what I got, but I didn't know if I was doing it right, so I did. That is correct. That's cool. Okay.
60.45.
Yeah, so did you, so like I just multiplied 1.645 times 50 over the square root of 25. So 10 over 5. I mean 50 over 5, which equals 10.
Square root of 25, which is 5.
Yeah, the square root of 25 is 5.
Uh-huh.
So I calculated 50, the omega 50 divided by 5, which is the square root of 25. So that's 10 times 1.645, which is the z-score for 90% of the area.
Okay.
So that was 16.45.
And then number 4, I think it's B or C.
Okay, so x is a point estimator, do u is a point estimator of x. O is, I mean, omega is an interval estimator. Oh, that was in the lesson. Oops. Where? Oh, my lesson's over here. That's right, I moved it. Oh my gosh, the probability app had 90 down further. Should have just scrolled. I didn't remember. Okay, we did that.
If x is within 2 standard deviations of u, then u is within 2 standard deviations of x. It may seem silly to state it, but this is very important.
Yeah, they had the whole point of it versus point estimators.
Notice if we know O, then with approximately 95% confidence, U will be between the following two values.
So the sample mean is a point estimator of the population mean. The statistics above are all called point estimators. So we know the sample mean, or the X with the line over it, is a point estimator. But the U thing is a parameter. So it's not C. And omega is, so an interval estimator is a range of plausible values for a parameter. We can create an interval estimate by studying the point estimate and adding a structure error. So O itself is a parameter.
U is unknown. How do we know? How do we know?
I think it's B.
Short answer is that we'll never know for sure if X is close to U. This does not mean that we are helpless. The laws of probability, A point estimator gives us specific value. I think you're probably right, because that's what I was thinking. It was either B or C. I had chosen B. Seems like I got it from that statement that I read earlier.
Yeah.
Let's see here. Notice that if we know O, then approximately 95% confidence, U will be between, no, that can't be right because it's not X and U. If we collect a random sample population of externally distributed, no.
Yeah, it's B. Because O2, or whatever, omega to squared, or to the second power. I don't know how they pronounce these things because I don't see the videos. I don't see that. So I think it's B.
So if either one or two is met, then we can consider the sample mean X as a normal random variable with mean U and standard deviation. About 95% of the time, the sample mean X will lie within 2 standard deviations of the population mean U. Okay.
All right.
Sounds good. Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation O of 113. She collects a simple random sample size of 64 and computes X equals 526. Use this information for the next 6 questions. What is the point estimate for the true GMAT score? That wouldn't be as simple as the X and the standard variation.
So
Deviation.
there's the GMAT scores. They did an example of a similar one, I think. Formula for the confidence interval for the mean when the omega is known. Okay, so 95%, that's up here. That's 1.96, the z-score. So our formula is going to be, oh man, I'm a write down person. Where's my other? There's this column. So 95% confidence level. Omega is 113, n equals 64. And the sample mean is 526. So to put that together, the confidence level of 95% is 1.96. Oh, that's not the 3 digits. We need to go out 3 digits in case that matters. So I'll open the applet. Oh, darn it. It closed my stinking quiz. That's so annoying. All right. 95%. That's not correct. No, I want 95%. 1.960. Okay, that is it. 1.960. So the 0 drops off. All right, so to put that together, our formula is 526 minus 1.96 times 113 over the square root of 64, right?
Yeah, I'm just a step behind you here. That sounds right from what we did on the first equation.
Yeah. So it's actually going to be plus or minus, but we'll just do minus. Okay, so then we calculate that out, and I only change one thing in my formulas at a time because I just am weird that way. So it's going to be 113 over 8, which is the square root of 64, because 8 times 8 is 64. Right? No, it's not.
Yeah, it is.
No.
It's 8.
What's the square root of 64? Isn't it
8? 8 times 8.
It is 8, right? Yeah, okay.
Yeah.
I don't know why my brain was thinking that didn't seem right. Okay. Okay, so then 113 divided by 8, 14.125. So it's 196 times 14.125. And the order we do this in, hold on, what are we finding first? The point estimate, which is the sample mean. But we know it already because it's 526. Now I'm intrigued a little bit to see. So, okay, no, that's how we're doing. So section 4.12, that's what we're doing here. It's the same thing that we're doing. We calculated 3. Okay, so yeah, we're on the right track. It seems like according to the lesson. But I'm thinking we're going to do this part first. So that times 1.96. times 1.96. So 526 minus 27.685 is 498.315, so 0.32. 498.32. Yeah, no. Oh, I solved it. Okay. I made that way too complicated. We solved for the margin of error. But the point estimate, according to the definition at the very beginning, is the sample
So it
mean.
was really just 526 minus 113.
No, I did. So
Well, isn't that?
I did 526 minus 1.96 over 113 over 8, and then I did 1.96 times 14.125, and then in parentheses so that those are together. Then I did 526 minus the result. Can you see it? I just did it on my notebook.
Maybe. No, just looks like a blur.
Okay.
So that's okay.
So I got 498.32, but then I realized the point estimate, which was throwing me off a minute ago. Now I know why, because I was reading the top of it again. So the point estimate is the sample mean, so it's 526. So the first question, we don't have to do any calculations. They're just trying to have us identify what part of the equation of the formula is the point estimate.
So the point estimate is 526.
Yeah, it's the sample mean. Just because up at the top where it had that little chart, sample statistic and population parameter, the sample mean says that the statistics, of which the sample mean is one of them, are called point estimators because it's one number on the line. So that's what we're looking at. So the X with the line over it, or the sample mean, is going to be 526 because that's a given. They already gave it to us. So we're just telling them what it is.
Okay.
So we didn't have to solve anything for it, that one. That was silly. But that's okay because I'm guessing the next 6 questions will
like one more of those. What is the margin of error for 95% confidence interval?
Okay, so the M, that's the M equation. So that's M equals, I already forgot what M equals because I have to do it more than once to remember. M equals 2 times omega 113 over, I'm just going to put 8 because we know that it's the square root of 64. But let's see, do we need to do I don't know if we need to fill in with the 1.96 just yet. I think we do because we did it on the previous question. 2 times, we know 113 divided by 8 is 14.1125. So the margin of error,
This may sound like some question. What's the difference between margin of error and a standard deviation?
it's 27.69. So this right here is the margin of error. It was 27.685. And we actually round to the third decimal. I'm gonna see. Kids are watching Napoleon Dynamite. I got these songs in my head now.
Uh-huh.
Yeah, 27.685. Okay, did that make sense how I came up with that? That's what I got.
A little bit. I'm just looking in the book for other confidence levels here.
The lower limit. Okay, so the upper limit and the lower limit. So the lower limit is the minus. So it's 526 minus the margin of error. And the upper limit is 526 plus the margin of error, right?
Yeah.
So 526 minus 27.685 is 498. Whoa. 498.32. I think I already did that one, but I'm going to double check my mind. 526 minus 27.685. Whoa. 498.315. So yeah, round 3 decimal places, 315. And then the upper limit would be 526 plus 27.685. So 553,685. That's what I got.
Okay. What would happen to the width of the confidence interval if Gina increased the sample size? The width would decrease, right? Because the larger sample size, the more accurate the deviation and margin of error is.
553.685. Hello. What would happen to the width if you increase the sample size?
Increase.
It would decrease. The confidence interval would decrease if the sample size increased, because it would be a smaller
Generalized.
Variation, the deviation would
right.
be more
So
accurate.
it's a lower deviation, right?
Yeah.
Yeah. So I'm going with decrease too. What would happen if Gina changed it to a 99% confidence interval? Increase, no change, or decrease. Wouldn't it increase? Because just based on the multipliers, it would increase because 99% is going to be a higher multiple. So we'd be multiplying the same standard deviation divided by square root. Would be dividing that same number. Multiplying that same number by 99% instead of 95%, which is going to make it higher. So it would increase. Right?
Yeah, that kind of makes sense.
That's what I'm thinking. Because if we redid the whole thing with 99% instead of 95%, we'd be multiplying by 2.576 instead of 1.96. So that would make all the numbers bigger. So then the confidence interval would be higher. It'd increase. I'm sure there's another way to explain that, but that's the way my brain thinks of it. I'm going to go with increase. Let's see. Bright Bulb Company is planning a study to assess the average life expectancy of their light bulbs. The standard deviation is 400 hours. They want a 95% interval with a margin of error of 50. What sample size do they need? Oh, so we're doing backwards now. So we know the margin of error. So M is going to equal 50. So if we put 50 over there on the M side and plug in the other numbers, we're going to have 95%, which is 1.960 times the standard deviation of 400, so omega is 400, over basically the square root of n, because we don't know n. Is there an example of this so we do it right? Because we have the numbers to plug in. So okay, we know that. Oh, okay. So there must be an easy way. The trick is to solve the margin of error equation, m equals z of that for n. This gives us the sample size formula. So that's what we need to do now. We need to do the sample size formula to answer question 11. So this is section 5. This tells you the number of observations required in order to obtain a specific margin of error. So actually, it's a different formula. So when we're reversing the formula, that makes sense because all I did is take out the numbers, but we need to actually reverse the formula. So we're going to do n, solving for n equals 1.96 times 400 over the margin of error of 50 times 2. Do you see where I'm seeing that?
Yeah.
And that makes sense because if you can't look for a square root without, to look for a square root, you multiply, or you put it to the second power to get something the opposite of square root. So in this way, then, we're going to do 1.96 times 400. So we're at 784 over 50. Divide that by 50. Equals 15.68 squared. So 245.862. Round to the nearest whole number because you can't have partial people. So the sample size would be 246 people. Is that what you get? Or do we need to walk through it again? Because I just kind of... Do you need a reminder?
It's fine.
Did that make sense?
Average life expectancy for a light bulb. Okay, I was just thrown off. You were saying people. Like, they're not people, they're light bulbs, but you still need to round up to a whole item.
Oh, true. Yeah, sorry. I was just thinking, yeah.
No, you're fine, you're fine. Okay. Mean salary of actuaries is U equals 100,000. Standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean. You are not sure if it is higher or lower. Well, it's lower. We don't have to guess that. You set up a hypothesis test with level of significance A equals 0.05. HOU is 100,000. HO equals whatever thousand. Okay. You collect a simple random sample of N36 women's salaries and find that X equals 111,000. What is the lower limit of this 95% confidence interval? Huh.
Okay. Well, let's.
So 36 women and
Confidence.
average salary of 11.
Okay, the mean. Okay, so the mean salary equals 100,000. That's the population parameter. Standard deviation is 36,730. That's our standard deviation, or omega. And you want to know if the mean salary for women is different than the population mean, but you're not sure if it's higher or lower. So you set up a hypothesis test. The level of significance of alpha equals 0.05. And the null is and the alternative is that it does not. You collect a simple random sample, so n equals 36 of women, and find that the sample mean is 111,000. Okay, so what do we need for just what we need here in the confidence interval? We already know, we know the sample mean, we know the sample size, we don't even need the level of significance yet. We just need the standard deviation. Right? I think that's right.
We need their average salary with this group of women.
Okay, so what we're looking for is the lower limit of the confidence interval. So first we need to find the margin of error. So that's M equals, with a what percentage? 95%. So 1.96 times standard deviation 36,730 over, well, I'm just going to say 6 because that's the square root of 36. So save a step. So then 36,730, woo, divided by 6 is 1.96 times 61,21,666.7. Give us that one. Okay, so that times 1.96 is 11,998.4667. So our margin of error is basically give or take 11,998. That's the lower limit. So it's the lower limit is the sample mean of 111,000 minus 11,998.4667. So the lower end of it is 99,001.53. And then the upper limit would be 111 plus 1198, 467. Upper is 122,998.47. Oh, nearest whole number, so 99,002. Okay, how did you get the same thing? I don't know if I did that right. I just guessed.
To be honest, I'm kind of halfway falling asleep. I'm sorry.
Oh, sorry.
No. Let's see here. And that was, you did 12, right? That was 13.
12 and 13 both. I figured if they're going to ask for lower, they're going to ask for upper, so I did both of them. So I got 99,002 for 12, and I got 122,999 for 13.
There's a lower limit of 95% confidence level. Okay.
I think 14 is D, all of the above.
There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are:
None of the others give you 3 options. It's kind of a
population, O is known, X
really
normally distributed. Simple random sample is drawn from the population. Yeah, I think you're right. You have to have all of them out, don't you? If you have another variable like the if you have the z-score, does that replace the x's or o's? Let's see.
But it only gives us 3 choices. We can't pick. Can you pick more than one?
No, but what I'm saying is, it's saying these are the requirements that need to be checked. So what I'm saying is, if you don't have the O, can you still figure it out if you have other things? Does that make sense?
Oh, true. But you still have to figure it out before you can calculate the confidence interval. Like you have to determine the O. Even if you don't know it, you have to guess it, right?
Yeah, you're probably right.
Because you have to have something. I'm just thinking, I'm going to submit it. I'm going to guess and see if I'm right. And if I'm wrong, I'll change it.
What did you have for 12 one more time?
12 was 99,002.
99 what?
99,002. So 99002. Okay, I got 100%. So it is D on that one.
Okay.
And 12 is also right. So that works.
And then 13 was 122.99.
999.
122.99.
122,999, but not point. It's 122,000.
Okay. Yeah.
So 3 is 16.45, 4 is B, 5 is 526, 6 is 27.685, 7 is 498.315, 8 is 553.685, 9 is decrease, 10 is increase, 11 is 246, 12 is 99,002, 13 is 122,999, and 14 is D.
Yep.
I think we got it all.
Well, thank you. I'm sorry it was not a lot of help tonight.
No worries. I get it. We're good. All right. Well, I will drop the call and you can go to bed and we will chat Thursday, right?
Yep.
We don't have an exam this week, right?
No.
I don't think. Just my other class does. Okay, cool. Well, have a good night. I'll talk to you later.
Bye.
Bye.